Hello class, this is Mr. Hasty. We're going to start today with a review of the washer method. So before we begin a review of the actual calculus, let's remember what a washer is and why we would use the washer method. So a washer is a circle with a circle cut out of it. The technical math term for that is an annulus. Now, we're going to be using the area formula for this, and the area formula is simply pi big R squared minus pi little r squared. Big R being the distance from the center to the outside circle, the larger circle, and little r being the distance from the center to the inside circle. This formula basically amounts to the area of the big circle minus the area of the little circle. So why would we need that? Let's look at our problem. Find the volume of the solid created by taking the region bounded between y equals e to the x and y equals x plus 2 and rotating it around the x-axis. So I have a graph of those two curves pulled up, and we can see they have this bounded region between them. Okay. If we visualize the rotation of that around the x-axis, what we will notice is that there's essentially a hole in the middle from the red curve, y equals e to the x, to the x-axis. There's empty space. As we rotate, we'll create circular cross sections, but because there's empty space in the middle, what we really create are washers. I'm going to do my best here to draw a model of what that's going to look like. So what this is going to look like is, if we notice that the outside's a straight line, which is going to give us a view of a truncated cone. Truncated just means that the tip of the cone has been removed. And we would have that, except the issue is the inside has been hollowed out from a curved section. So inside of it, it'll be something like that, meaning we have this hollowed out space in the middle. So what we do in these problems is we start by taking our area of our cross section and putting it in terms of x, in terms of these equations that we're given here and here. So as we do that, the area for each cross section, if we cut a slice of our volcano looking shape, we will have the axis being right here, our big radius being the distance to the line on the outside. So that's going to result in pi times the big radius being defined by the line x plus 2 squared minus pi times the curve e to the x squared. That second part comes from the fact that if we cut out a cross section, the smaller radius is going to be this distance right here. That was not good. This distance right here, essentially the radius of the inner circle. Now, once we have an area established for a cross section, the way you find the volume, sorry about that right there. The way you find the volume is you integrate that particular area. I'm going to simplify e to the x squared as e to the 2x using exponent properties. Now, we do need bounds here. So I'm going to use Desmos. You would use your graphing calculator. You would use second calc intersect. But I can see on my Desmos here that they intersect, and we only need the x values, at negative 1.841 and again at 1.146. So My lower bound is negative 1.841. And my upper bound is 1.146. Now, I would assume you would do something like this on your calculator. You could do it by hand, but either way, you're going to get roughly 17.099 units cubed if you wish. So that's kind of a brief review of the washer method. Remember that if the solid that would be generated is completely solid with no hollowed out region in here, you don't need to do the minus pi little r squared. So this has been our recap of the washer method, and we'll be moving on next to something called the shell method. All right. See you guys next time.